I'm tackling a machine learning problem, predicting house prices using AdaBoostRegressor from Sklearn. I've built a model, and it looks good based on the R-squared score. However, I've noticed that even tiny changes to the input features, like house size or location, lead to big changes in the predicted price. That's a problem because a reliable model shouldn't be so sensitive. I have some options to explain this sensitivity problem, and I need to identify which is correct. This is a multiple-choice question aiming at identifying which statements accurately diagnose the model's sensitivity and how to solve it. Option A suggests that my model is learning the training data too well, overfitting, because the _learning_rate, which controls how much each week learner contributes, is set too high. Lowering it could make the model less sensitive to small input variations. Option B proposes that the number of weak learners, n_estimators, is too small. This could lead to underfitting. The model isn't complex enough to capture all patterns and becomes overly sensitive to noise. Adding more weak learners could help. Option C focuses on the base estimator, often a decision tree. If it's too complex, deep tree, it might overfit and be sensitive to slight input changes, independent of AdaBoost's settings. I could address this by making the base estimator simpler, for example, by limiting its depth. Option D suggests that the problem is unrelated to my AdaBoost settings. Instead, it proposes that outliers or strongly correlated features in my training data are the problem. This means, I'd need to clean up my data first. I see this option suggesting that problems like outliers, data points significantly different from others, or features that are highly related to each other might be causing the model's sensitivity. This isn't directly related to AdaBoost's settings but to the data itself. I'd deal with this by cleaning the data first. For example, I might remove outliers or create new features that combine the effects of highly correlated ones. To fix problems from outliers or highly correlated features, I would need to pre-process the data. That means I'd clean it up, maybe removing outliers or transforming the features to be less correlated, before I even train the model. This line is important because it helps highlight the distinction. Options A, B, and C focus on fixing issues with the AdaBoostRegressor model's settings, hyperparameters, while option D deals with pre-processing, meaning changing the dataset before using the model. That's a key difference to note. I see a problem. Your AdaBoostRegressor model, which predicts house prices, is too sensitive to tiny changes in the input data, like the house's size or location. This means even a small change in the data leads to big jumps in the price prediction. This isn't good because our model should be more stable and consistent. We need to figure out why this is happening. One possibility is that the learning rate is too high. Think of the learning rate as how much the model adjusts its predictions after each training example. A high learning rate means the model learns too quickly and might latch onto small quirks in the training data, overfitting, making it sensitive to even slight input changes. I'd suggest reducing the learning rate to make the model learn more gradually and robustly. Another possibility is that the model doesn't have enough estimators, n_estimators. Estimators are like the building blocks of the AdaBoostRegressor model. Too few estimators mean the model can't capture the complexities of the house price data well enough. This underfitting can result in high sensitivity to noise and variations in the input data. Therefore, increasing the number of estimators could make your predictions more stable. I also suspect the base estimator is too complex. AdaBoostRegressor often uses decision trees as its base. Deep, complex trees can overfit the data, just like a high learning rate. Overfitting makes the model react strongly to small changes in input. To fix this, I'd consider simplifying the base estimator, like using shallower decision trees. This is another consideration. Outliers, unusual data points, or high correlations between features can throw off the model. If the data has these problems, the model's predictions could be unpredictable, even without problems with AdaBoost's hyperparameters. However, this is not the main focus of the current problem, as the question specifically points to the model's sensitivity to minor changes in inputs. Let's keep that in mind for later. I'm focusing on how to tune AdaBoostRegressor's settings and prepare the data to make a more accurate house price prediction model. This involves adjusting parameters like LEARNINGRATE and NESTIMATORS, and also cleaning up the data to deal with things like outliers. It's like fine-tuning a recipe, getting the ingredients right and adjusting the cooking time for the best result. My model is too sensitive. Even small changes in the house features, size, location, age, cause huge shifts in the predicted price. It's like the price is wildly fluctuating. I need to find why. This sensitivity shows there's a problem of either overfitting or high variance. I think the LEARNINGRATE is too high. This means the model learns too aggressively from each individual data point, leading to overfitting. The model is fitting the training data too closely and it's going to perform poorly on new, unseen data, hence the sensitivity. Reducing it will help the model generalize better. Maybe the model doesn't have enough decision trees. NESTIMATORS is too low. It might be underfitting, not capturing the patterns in the data properly. This makes it sensitive to noise, and small input changes can significantly change the prediction. I should add more trees. The base estimator, the type of decision tree used, might be too complex. Even if AdaBoost is well tuned, a highly complex decision tree can still overfit. Simplifying it, maybe by limiting its depth, would reduce overfitting and make the model more robust. There could be outliers or highly correlated features in my data. These would affect model performance and could lead to sensitivity. But this issue is separate from the AdaBoost parameters themselves. It's a data quality problem. I need to address this by pre-processing my data first. I will reduce LEARNINGRATE to make my model less sensitive to the training data and improve its robustness to unseen data. I'm gonna increase NESTIMATORS. More trees will help the model to capture the underlying patterns in the data more effectively, thus reducing sensitivity to noise. I can make the decision trees less complex. This helps avoid overfitting by preventing them from fitting noise in the training data. I need to clean up my data by dealing with outliers and reducing the correlation between features. This is important for model accuracy but not the primary solution for the described sensitivity problem. I see a problem where the model's predictions change dramatically with even tiny tweaks to the input data. This suggests something's wrong. The model is too sensitive. We need to figure out why. Imagine you're building a house with only a few bricks. The structure is weak and easily wobbles. A low number of estimators, N_estimators is the number of weak learners combined in AdaBoost, means the model is too simple. It underfits the data. Small changes in the input easily throw off this fragile model. I'll need more bricks, more estimators to make it strong. Think of the learning rate as how much each new piece of information changes your belief. A high learning rate means you change your mind too drastically with each new data point. This leads to overfitting, where the model becomes too specific to the training data and reacts wildly to new, slightly different inputs. It's like memorizing the answers instead of understanding the concepts. We need to be more careful and adjust the learning rate. The base estimator, often a decision tree, is like the foundation of your model. If it's too complex, a deep, branching tree, it's like building a house on shaky ground. Even small changes in the ground, input data, cause the entire structure to shake. We need to make the base estimator less complex to make the model more robust. Outliers are extreme values in the data that can disproportionately influence the model. High feature correlation means some features are essentially saying the same thing, creating redundancy and potentially instability. These issues are data problems, not model problems, and need fixing before improving the model itself. I'm analyzing how the hyperparameters of AdaBoostRegressor, a machine learning model that combines multiple weak learners to make a strong prediction, affect the model's sensitivity to small input changes. I'll focus on how adjustments to these parameters influence a model's robustness. AdaBoostRegressor is an abbreviation for Adaptive Boosting Regressor. The problem is that small tweaks to the input data, house features, lead to big changes in the house price predictions. This suggests that the model is either overfitting the training data or has high variance. Let's dive into why this happens and how we can fix it. A high learning rate means each individual learner has too much influence on the final prediction. Think of it like this. Each learner is shouting their opinion, and the final decision is overly swayed by a few loud voices. This can cause the model to focus too much on the training data, overfitting, making it sensitive to minor input changes. Reducing the learning rate helps each learner to have a more moderate impact, leading to a more robust prediction. If we have too few learners, n_estimators, the model isn't complex enough to capture the subtleties of the data. It's like having too few people judging a cake. You might miss some important details. This underfitting makes it prone to being swayed by noise. Increasing n_estimators allows the model to learn more intricate patterns, improving its ability to generalize and reducing sensitivity to small changes. The base estimator is the type of model AdaBoost uses to build its prediction. If this base estimator is too complex, like a very deep decision tree, it can overfit to the training data, making it extremely sensitive to small data fluctuations. Think of a base estimator as a single ingredient. We need to choose an appropriate base estimator. Simplifying the base estimator, reducing its complexity, reduces overfitting. Data quality issues, such as outliers, extreme values, or features that are highly correlated, meaning they provide redundant information, can absolutely mess up a model's performance, resulting in sensitivity to minor input changes. This is a data-related problem and not necessarily directly related to AdaBoost's internal workings. We would address this by data cleaning and pre-processing before feeding the data to the model. The problem is that my AdaBoostRegressor model for predicting house prices is too sensitive. Even tiny changes in the input features, like house size, location, or age, drastically alter the model's predictions. This suggests a problem with the model's complexity or how well it fits the data. A high learning rate means each individual, weak learner, within the AdaBoostRegressor has a very strong influence on the final prediction. This can lead to overfitting, where the model learns the training data too well and performs poorly on new data. That is the sensitivity issue I described. I can fix this by lowering the learning rate to make the model more robust and less prone to overfitting. A low number of estimators means my AdaBoostRegressor uses too few weak learners to create the final model. This can cause underfitting, where the model is too simple to capture the underlying patterns in the data. As a result, the model becomes highly sensitive to noise and small changes in the input. Increasing the number of estimators will give my model a better chance to capture patterns and reduce sensitivity. The base estimator, often a decision tree, is a core component of AdaBoost. If I'm using a very complex base estimator, like a deep decision tree, it can itself overfit, independent of AdaBoost's settings. That is, a complex base estimator might be learning noise, rather than useful information. Simplifying the base estimator will improve the model's generalization to new data. For example, if I use a decision tree, I can limit its depth. Outliers, unusual data points, and high feature correlation, where features are strongly related, can certainly affect how well my model performs. These problems can make the model sensitive to small input changes. However, unlike issues A, B, and C, these are data problems, not model problems. I would address them by pre-processing my data, cleaning up outliers and handling correlated features, but this isn't the primary reason for the sensitivity issue described.